Hi, grade nines. So today I'm just going to go over this new lesson very, very briefly. So we're starting a new unit. So we are now on unit 6, which is all about interpreting data. And you're going to notice that the video lessons that I do for this unit are extremely short. They're not really video lessons. I just mainly want to go over some of the technology tools that we use, mainly how to use Desmos to graph, so to plot points, and then to also find the line of best fit. But for now, I'm just going to quickly just recap all the really important information in the lesson. I'm not going to go through it all. This lesson is really long, but to be honest with you, it's pretty easy to follow. I think it's pretty self-explanatory. I don't think it should be too difficult. So essentially what we are doing in this unit is we're learning about how to look at trends. So a big portion of this really is about understanding variables and the relationship that they have. So we talked about this already. Variables are values that will change um, depending on the situation that we have. And normally we talk about independent and dependent variables. So independent variables affect the dependent variables. So for example, if you're looking at the hours that you study, so we know that the longer you study, the better your marks. The more you do homework, the better your marks. Another example of two variables that affect each other positively would be the more you eat, the more weight you gain. However, you can have negative relations, which means that one gets larger as the other gets smaller. So for example, in this one, the older you are, the less you run. So maybe we just run less distance. So in this case, if we look at age x, as our x variable, because it is independent and it will affect the amount of running that we do, we can see here that generally speaking, what's going to happen is the amount that we run goes down over time. And that kind of makes sense because when you're younger, you love to run. Kids run around all the time. And as an adult, maybe you don't run a lot, right? So that's obviously going to be going down in this case. And again, this is just a general trend that we see. It doesn't mean it happens all the time. And the last one here, the hotter it gets, the lower the heating costs. So generally speaking, if we think about, the temperature, as the temperature rises, so it gets hotter, we can see here that your heating costs, you're not going to need your heat as much, right? So your heating cost is probably going to go down because you are probably going to turn off the heat because it gets pretty hot and you won't even need it that much. And obviously when it's colder, over here at the very beginning of the graph, we can see that it's actually quite high. So that's all we mean by the relationship between two variables there. Then we talked about discrete and continuous variables. I'm actually going to skip this over because we talked about this already. Hopefully you're pretty clear on it. Please make sure you look at the examples. And if you're not sure, ask in the discussion board. But I think for the most part, most of you will understand it. So to do a so to see if there's a relationship or not, you want to put this on a graph, and this is when we use a scatter plot. You learned about scatter plots in elementary school. Basically, you plot out the points. We've actually been doing scatter plots already. The only difference is that we've been focusing more on scatter plots where we have a perfect straight line that goes through all the data. Now, the only difference in unit 6 is that you're going to see that we don't always have a perfectly linear relation. It's actually not going to happen a lot. But we're still trying to see if there are any sort of patterns, even if it's not a perfect linear relation, but maybe there is a general trend or a pattern that we see here. And that's really the difference between unit 3, 4, 5, when we looked at linear relations, and unit 6 is that in unit 6, we're kind of looking at data in real life, which data in real life is messy. It's not always going to be a perfect linear relation, right? But even regardless, we can still always see patterns. So let's say that you're trying to see if there's a relationship between the height of the fathers and the height of their sons. Obviously, I think most of you can kind of see here before we even start this question, there should be a relationship between them, right? It's not a random coincidence. The father's height will affect the son's height. So generally, how does this work? Well, the height of the son will be dependent on the height of the father. And so in this case, it's actually extremely important that the height of the fathers is the independent variable. So when we actually graph this out, the height of the fathers should go on the x-axis and the height of the sons should go on the y-axis. And the reason for this is because the height of the fathers will affect the height of the sons, not the other way around, right? Hopefully that makes sense, right? It's not like because, like let's say I have a child, just because if I have a son, just because I am Like if my son is tall, that doesn't mean that I will automatically change, right? That's not how it works. The height of the father will affect the height of the son, not the other way around, right? So because the son is tall doesn't mean that the father will all of a sudden start growing. Doesn't work that way, right? So this is an example of when it is extremely important that you understand the difference between independent and dependent there. So correlation and trend, we already talked about this, is basically kind of measuring out or kind of seeing what the relationship is between the two variables. And we kind of started to see what I meant by positive relationship and negative relationship. So in the first couple examples that I gave about, I think the first one was about the hours that you study. So studying hours and your marks. I think most of us can agree that generally what happens is the more you study, the higher your marks are, right? So generally speaking, it's going to look like that. It's going to be a strong correlation. Obviously, there's going to be exceptions to the rules, but generally speaking, it's going to be true. And then a strong negative relation is kind of like the one we talked about where, the older you get, the less you run, right? So your age, as the age goes up, the amount that you run is going to go down, right? So that would be an example of negative correlation. Just so you know, we talk some of the examples talk about moderate relation, strong, whether it's moderate, strong, or weak. I won't worry too much about that. Just focus on whether it's positive, negative, or no correlation. No correlation basically means that there is, well, the name says it, no correlation at all, right? There is no relationship between the two variables, right? So it's just a random two random variables that don't really affect each other in any way. So I'll skip over this. You can watch this video on your own. It's pretty interesting. Outliers are basically values that don't fit the norm. I'll also let you read this on yourself because I think this is pretty self-explanatory as well. So let's just look at a couple quick examples and see what relationship we see. So obviously here we see that the number of missed classes and the exam score seem to have some sort of relationship with each other. And generally what we're noticing is that as the classes that you miss keeps increasing, your exam score will decrease. So the more classes you miss, the lower your score. And that should hopefully make sense because obviously you're missing class and then you won't really know what's going on. So this is a negative relation, a negative correlation here. IQ and height. IQ, if you're not sure what that means, it's in a test that they use to assess intelligence. It's not very accurate. So basically, is there a relationship between intelligence and height? As far as I know, I don't think that being tall makes you smarter or being short makes you smarter. I don't think there is any sort of relationship at all. These are just two random variables that don't seem to affect each other. Here's another one about shoe size and height. I'll let you just kind of think about this one and do it on your own. And this one's just kind of interesting. Size of a TV and the average time spent watching TV. So there seems to be no relationship, but a lot of people have argued that there could be a relationship between it because obviously if you're watching TV more, then you're more likely to invest in a large TV. So maybe there is a relationship, but as far as we know from what we can see on this graph, there doesn't seem to be any relationship, right? It's completely scattered. So I will let you kind of go over this on your own. Basically, in the nutshell of this is that in all those examples that we saw, the two variables were actually occurring and were kind of following a pattern with each other. But just because they kind of follow a pattern with each other doesn't mean that they directly affect each other. So for example, if you look at this graph here, we can see that ice cream sales seem to peak at the same time as shark attacks. Does that mean that the ice cream sales are causing the shark attacks? No. And it doesn't mean the shark attacks are causing the ice cream sales. It doesn't make any sense at all. What's really happening is there's actually a third variable that's kind of affecting both of them. And that's the fact that we are in the summer, which in the summer, everyone knows it's hot. So what's happening in the summer? In the summer, you're going to be eating ice cream. So here's ice cream there, and you're going to be swimming in the beach, which means that you're more likely to see a shark. There's supposed to be a shark there. So it's really the summer that's causing these two other variables to occur at the same time. Doesn't mean that they actually directly affect each other. So just be kind of careful with that. There might be a small, tiny question like that on the upcoming assessment that we have for this unit. Just being careful that you understand that correlation isn't the same as saying that the two variables directly cause each other, right? Which means cause and effect. So there might be correlation, which means that the variables seem to move at the same pace. So they're both increasing or they're both decreasing at the same time, but doesn't necessarily mean that one directly causes the other. I'll let you also read that as well. And I'll let you kind of skip over this. Like I said, I'll let you just read this on your own. It's pretty self-explanatory. Again, this one's another good example for you to just kind of read. And again, this is pretty self-explanatory as well. So I want to get to the main part that I wanted to show you. How to use Desmos to actually plot a scatter plot here. Now, you can do this by hand. That's no problem at all. But I'll be honest, if you are doing this by hand and then you are later on finding the line and curve best fit, and we'll talk a little bit more about that in the next lesson, you definitely will need technology to kind of help you out. You can definitely do it by hand, but it does get a little bit tricky. So I'm just going to show you on Desmos here what it kind of looks like. So I actually did this one already for you. So I'm actually going to show you from scratch how you would actually put the table yourself, because you're going to have to do this for some of the homework questions. So you're going to go to the plus button, the plus sign right there, and you're going to click on table. And when you click on table, you're going to get an X and Y table of values. And all you really need to do is simply type in your values there. So if we go back to our example in the lesson here, we were given a table of values with the mother's heights and the girl's heights, so their daughter's heights. So what we're going to do is we're going to type in the heights into this table. And I would suggest putting it in meters. Centimeters. It's going to be easier for you to interpret it instead of meters. Meters is, you're just going to get really tiny values. It's going to be a little bit hard to see relationship there. So I would switch it into centimeters here if I were you. And what we're going to do now is we're simply going to plot the points in order. So for example, if I go back here, I have, kind of have to juggle between the two screens here. So 162, and then that matches up with 155 for the daughter's height. So I'm going to put 162 and 155 right there. Now you can't see the point because obviously we are really zoomed in, but now if we zoom out a little bit, we should be able to see the points that we want. And of course, if you want to change your scale, I think I mentioned this already, go to the wrench and then you can change your X and Y axis, where it starts and where it ends and how much you increase by. But if you just zoom out, then you'll be able to see the points there. Okay, so make sure you zoom in and zoom out by clicking on the plus sign or the minus sign, okay? And then all you're doing is you're plotting out the rest of the points. So 153 and 155. Let me just do one more so you kind of see here. So I go to the next line, 153 and 155. And then when I'm done, I don't even have to press anything. It just automatically shows the points there. Now, if you are doing a line of best fit, obviously you're going to complete this table first. And then I'll talk about this in the next lesson. A line of best fit is basically the line that goes through most of the data here. And you can kind of see here that even without doing any sort of line, we can generally see that as the mother's height increases, the daughter's height also increases. And again, not a coincidence, just like the example that we talked about for the father's height and the son's height. They seem to affect each other, right? And it seems like, generally speaking, the taller the mom is, the taller the daughter will be. So if you want to actually draw a line of best fit, and I'll talk about this in the next lesson, you're going to type this in exactly. And it's extremely important that you type it in exactly like this, Y1. And then you're going to be putting a little dash here. It's, if any of you speak Spanish, ñ, right? You're going to be looking for a little squiggly line. And if you're looking on your phone, you might have to press the ABC button to see more characters, and you're going to click on that button. And you're going to write mx1 plus b. If you type that in, it actually does the line of best fit for you. And again, I'll talk a little bit more about what the line of best fit is there, but I just mainly wanted to go over how to actually use technology to plot your points. And that is it. Like I mentioned already, this lesson was pretty self-explanatory. I think you'll be okay to go through the rest of it on your own. Just wanted to go through the main stuff. All right.